Here we go with differentials. This will be example number 4.2. And so it talks about a conical sand pile, which a cone would be described by its radius and its height. And of course, since we're dealing with a cone, I'm sure you all definitely want to see the cone head here. All right, and let's go ahead and put a hat on while we're at it, rock chalk here. All right, so, we're talking about the volume of a cone. And again, that would be reliant upon a geometric formula. And what is the volume of a cone? Well, again, you either go look it up or I put it in the notes here. So we see that the volume of a cone is determined by the formula 1/3 pi r squared h. That would be the formula for the volume of a cone. All right, now, that would be in general. But if you look at the question, it mentions that we have a cone here, a conical sand pile, and it says that the radius is 14 inches, all right, and that the height increases from 7 in the first cone to 7.1. So notice that the second cone is a little bit taller than the original. And so here's the thing though, it's assumed, I would guess, that the radius stayed the same from one cone to the next. And so the point is, the radius is constant. It's 14 in both cones. So the point is, the fewer variables, the better. So for our particular situation, we can say that the radius remained 14, whereas the height changed from one cone to the next, didn't it? So let's take advantage of that and fewer variables involved in the question. So anyway, 14 squared, I believe, is 196 over 1. And so that 196, that would be 196 over 3 pi h. There would be our general formula for this situation. And again, I point out that the radius remained the same, and the height is what changed. So now we want to know what's the change in volume between this cone and this one. And the change in volume would be called dV, change in volume. So again, we will now go back and talk about that if we want a differential, the change in a particular variable, we take the derivative first. So, it's just like this is y and this is x. So if we differentiate this, dV dH, just like dy dx, equals, so the point is we're differentiating with respect to h, and the derivative of this with respect to h, that's a constant times h. So wouldn't its derivative with respect to h be simply that constant? All right, and that would be the rate of change between these two variables. But if we want to know what the change in volume is, see, this again is where we transform it from a derivative into a differential. And because again, the question said it didn't want the rate of change between the volume and the height, it wanted the actual change in volume. That's again called dV. So, clear fractions, and the change in volume ends up equaling 196 pi over 3 dH. All right? Now what? Well, the dH would be the change in the height from the first cone to the second cone. And so, to get a specific value for this, we will say, all right, we've got 196 pi over 3, and the change in height from the first cone to the second cone is how much? 0.1 of an inch. So that's the dH, 0.1. And then it's just a matter of crunching that out in our beautiful calculator here. So Beldar will grab his calculator, his magic computing machine, and do the arithmetic. 196 pi divided by 3 times 0.1, and we get, I hope I did that right. I am looking at it one more time to confirm, and it looks like it's 20.525072. All right, and volume, keep in mind, would be cubic and inches. So this would be cubic inches. It's positive, the volume went up from here to here, and so that volume changed by this many cubic inches from the original cone to the other cone. Does that hopefully make sense to all of you? I hope so. I did my best. Have a wonderful evening. Now go eat yourself an ice cream cone. Mass quantities.